So guys, recently I have uploaded a video that is discussing about your natural frequency of your structure, right? And after watching that video, one of you have asked me to do more videos about structural dynamics, and this has enforced me to make more videos based on structural dynamics. Okay, so this video is one of them, and it is all about the undamped system. And in this video you will learn what is undamped system and also how to solve the undamped system to find the maximum amplitude and also the natural frequency that I have already discussed. And also in this video you will get a glimpse of that, right? So if you are new to this channel, please do subscribe, and also don't forget to join the channel, right? So what is undamped system? Undamped system is simply where there is no such force which causes a system to stop its oscillation. That means, let's say you have a system like this one where there is only spring. Now if you apply some force to move this mass towards this right direction with amount, let's say y, right, and then release it, what will happen? Simply it will oscillate like this, right? And if you have some extra force, let's say you have a extra resistance like this which is damped, and it will cause your system oscillate like this. That means eventually it will be fade out. So the second one is your damped system, and the first one is your undamped. So in undamped system, the system will oscillate infinitely because there is no such resistive force, right? That is known as C, or damping factor. So in the undamped system, let's try to solve this problem. So first draw the free body diagram, right? If there is a mass M that is attached with a spring and you are applying some displacement y, so the free body diagram will look like this. This is M. So due to acceleration, force is from Newton's law, M times acceleration. This is acceleration, y double dot, and from Hooke's law, the force is, yes, spring constant time the displacement. So this is from Hooke's law, this is from Newton's law. And to maintain the equilibrium, the summation of these two forces must be equal with 0, right? Well, now what is the solution? So definitely this is a second order differential equation, y double dot, that is simply the acceleration. That means velocity is dy dt and acceleration is your d2y dt2. This is your acceleration. So this is second order differential equation. What is the solution of this? Yes, to solve this differential equation, what you have to do, you have to assume a function, let's say y is equal to a cos omega t, or y is equal to b sin omega t. Okay, and if you apply this y value in this equation, you will get, right, minus m omega square plus k. And I have already discussed the detailed solution of this one in my previous video, where I have discussed about the natural frequency, that is your omega, right? And from this equation you got the natural frequency omega square is equal to k by m, or omega is coming as square root of k by m. Okay, so in previous video you have understood what is natural frequency. Now to proceed further, well, just superimpose these two equations. So to solve our equation was this one, our equation, this one was your equation, right? And you have already tried with y is equal to a cos omega t, or y is equal to b sin omega t, right? Great. So if you superimpose these two equations, you should get a complete solution of this differential equation, that is y is coming as a cos omega t plus b sin omega t, right? And from this one I can say, well, initially let's say the system, this was our system, and at the very initial stage our displacement was, let's say, y0. That means when t was 0, the displacement was y0, right? And when t was 0, let's say the velocity was, that means dy dt or y dot, this was v0 at initial condition, or you can say this is our boundary condition, right? So from this equation we can say that y dot or dy dt is coming as minus a omega sin omega t, and here it is coming as plus b omega cos omega t, right? So this is y dot, right? So at t is equal to 0, y dot is equal to coming as, this one is 0 and this one is coming as b omega, right? And this is nothing but v0, because our initial condition was that at time t0 the velocity was v0. So this is v0, okay? So from this equation you got the value of b, that is coming as v0 by omega. And what is omega? Yes, this is natural frequency, right? And by the way, natural frequency is actually known as, if natural frequency is f, then omega is equal to your 2 pi f or n. This is the natural frequency, or n you can say, this is coming as 1 by 2 pi square root of k by m. This is the exact equation of natural frequency. But when I am talking about omega, actually I am talking about this one, right? So you have got the value of the b, so it's time to find the value of a. So that is also easy, because at time t is equal to 0, our y was y0, the first condition, and this was the second condition. So from the first condition t is equal to 0, simply apply the value of t here in this equation, right? Here apply t is equal to 0. So y is coming as a, and that is simply y0. So the value of a is equal to coming as y0. We have got the value of the constant. So now you can solve the equation, right? So let me erase everything. Just remember these two value, okay? So a is coming as y0 and b is coming as, yes, b is coming as v0 by omega, right? Okay, now our initial equation was, yes, y is equal to a cos omega t plus b sin omega t. If you simply put the values of these two constant, you will get y is equal to as y0 cos omega t plus b is v0 by omega sin omega t, right? So this is the complete solution of an undamped system. So when you have some undamped system like this, right, with initial displacement as y0 and initial velocity as v0, then the equation for its oscillation is coming as this one, right? And here, well, omega is simply this one, right? So you have got the complete solution of an undamped oscillation. Now if you plot it, you can definitely get an equation or a graph, right? If you plot this equation, you should get a graph. So what would be the graph? Well, so if this is, let's say, our amplitude value, that is y, and along this x-axis we are plotting time t, right? So when t is equal to 0, what is the value of this equation? At t is equal to 0, you are getting y is equal to y0. This one is 0 and cos omega t is equal to 1 at t is equal to 0. So initially you have some value that is y0, right? And also here, from here the oscillations start and it goes like this, right? So in this point here, if you simply get a first order derivative that gives you the velocity or the tangent at this point is the velocity at t is equal to 0, this is coming as v0, right? So this is v0, and here you can see that as we have started from this one, so if we projected this here, we should get our 0 amplitude value, but actually we cannot go in negative time. So this difference, this is known as your phase difference. Okay, so to get this phase angle, what you have to do? You have to convert this equation into a equation like this one. What is that? Let's say simplify this equation, that is y is equal to, let's say, c times sine omega t plus alpha, and this alpha is the phase angle. Okay, that means it is ahead of its original position. So it is starting from the y is equal to 0. That is why it will always have a phase angle, that is alpha. And you can easily find this constant, that is c. How? Again, simply use the trigonometric value. From that you can find the value of alpha as well as c, right? So that's it. That's all about the undamped oscillation. In the next video, if you find interest in this video, definitely in the next one I will try to solve the damped oscillation. Okay, so in damped oscillation, what happened? In addition to your spring with the system, spring constant, we also have some extra resistance that is known as damp coefficient C. So we'll try to solve that one. If you find this video useful, and also if you show your interest, definitely I will try to solve this damped oscillation also. Okay, so thanks for watching, and also don't forget to share it